Welcome back to my channel. My name is Brian Kafiki. I'm a data and AI enabler. Cheers with my R mug, wearing my Power BI shirt, because I usually brand myself with things. And this topic is one that I find really cool. I've worked on this for a while because I wanted to get a good presentation that really showed you how to put R and SQLite together to step up your data analysis and analytics work with R. And I think you're going to be really impressed. SQLite is a really cool product and I wanted to demonstrate that. So before I do, though, I want to mention that if you do any kind of analytics in the big data space, specifically Apache Spark, then you want to take a look at my book, which I just published, called Master Azure Databricks. Databricks is actually a service that was created. The company itself was founded by creators of Apache Spark, which is an open source, scaled up big data analytics platform. And Databricks is a wrapper around that to make it easy to use and provide all kinds of cloud-based type services. So this is Apache Spark based. And this book is a comprehensive resource. So if you're using Apache Spark even only, I think you'd find it extremely useful because I go a lot into things like PySpark, SparkR, SparklyR, machine learning, and things like that. But I also delve into Azure and Azure Databricks because that's a sort of a merge of the product Databricks, which also runs on AWS, and Azure to see how they interface and interact. This really is the most comprehensive book on the market. I wrote it because I kept searching for one, and every time I thought there was a good one out there, I found it was very lightweight and it was like very high level, almost like a marketing pamphlet as opposed to a programmer's reference or manual. So this takes you step by step using a use case like the company's doing this and follows through. It's available on Amazon, so if you're in that space, take a look at it. I worked extremely hard on it, and it is only available right now as an ebook. You can get, it's a Kindle, and it's available on Amazon. You can get a Kindle reader on any device just about there is, from your phone to any kind of tablet to any machine. So that's not a problem. The book in print, which I am working on, but it will be over like 650 pages. So it's not something you're going to lie on the couch and have it pressing on your chest. I've had books that get to a certain size and it doesn't work well that way. So a printed version probably is a little tricky. It has all kinds of materials that go with it. So the ideal thing is to kind of have it on a tablet and then be going through on the computer and step by step, or keep two windows open if you're reading it that way. So where are we going in this presentation? I'm going to start by talking about what SQLite is, why we would want to use it, the architecture, and using SQLite with R. So what is SQLite? It's an open source, lightweight, run anywhere database management system. And I mean it runs anywhere. It runs on just about any device. So if you got a phone, you got a Android tablet or whatever, it probably has it or could have it on there. It's very heavily used in IoT types of situations, as well as web apps and things, because it's just, you got a nice database that you can persist anywhere and it doesn't take a lot of space. It's a small footprint. It has a generalized API and different languages. A lot of languages have wrappers written around their libraries that will allow it to use SQLite. Python is completely a default database that you get with Python. And R has a really easy way to just load a wrapper in and use it as well. It is a full SQL implementation, so it's like a SQL ANSI standard. It has a lot of all the things that I know and love, like common table expressions, lots of, the joining ability, the ability to create views and create tables, add indexes, so all that kind of stuff. And it has like rich database management system functionality, including performant things. It will do a lot of things to improve performance and things like that. So why use it? Well, in my experience, when you're trying to do any kind of analysis work with data, whether your goal is to train machine learning models, do visualizations, or just get some metrics or whatever you're trying to do, you ultimately need a place to store the data. You're going to end up going through layers. I've got to get data from here. I've got to get it from here. Somebody handed me a spreadsheet that they want me to merge in. And usually it has to be cleaned up. You got to go through a lot of work. You got to figure out, what do you have? Is it right? That kind of thing. And then because of that layering, you need a place to put it, and you want to be able to query it. Like after you go through layers and you kind of get it to the point where you're ready to use it, that's basically kind of like an ETL process you've done. And you want to keep running that every time you use the data? Probably not. You may be somebody who puts it out into a CSV file or something afterwards and say, I'll come back and work with it later. Again, that's okay, but it's not as easy, I think, or intuitive to use, and you can't really put any logic into a CSV file. So here you have a database. You can use views, you can use tables to store things, and you can query it. So that's the idea really behind this. There's zero configuration Just set it and go. And you can stage, clean, and transform your data for analysis. And I think of it like building a local data warehouse, whether you use dimensional modeling, which is facts and dimensions, or you just kind of want to keep it as a place to store data as a way to persist it. Nice thing too, which is easy to overlook, is the code and the data can be shared with anyone. So you can say, here's my R notebook or my R script, and here's the database that goes with it. So it's great for any kind of studies or analysis where you need to hand somebody your results, especially if you do any kind of things in the sort of academic world where you're publishing papers and stuff. You want to make sure it's very easy for someone to just use it. Oh yeah, and it runs on all these different platforms. That was my underlying thing there. Now I do want to point out, I don't recommend putting any kind of confidential information in the SQLite database, because the one thing it does lack is any security features. It doesn't have any things like grant and deny. And by the way, I mentioned, it's just a file, so anybody could copy it and go anywhere. In my experience, that's okay, because you don't typically need personally identifying information, things like social security numbers, names, even birth dates. You might need some parts of a birth date, but hopefully you don't need the actual birth date, things like that, because then you get into a problem where somebody could get it, and that's a problem for security. You're like, obviously HIPAA compliance, financial information, etc. So that's the only thing I'd be careful of. I tend to aggregate data and use it, or at least I would just drop those columns out before you bring them in. What about the SQLite architecture? Well, imagine we have this file. Now, AdventureWorks, I'm going to kind of copy this idea. Microsoft has a training database that they've used for years called AdventureWorks. The idea is it's a fictional sporting goods company, and they have a database and a warehouse, and they use it for training and demonstrations and everything, which is a great idea because you always need data that you can demonstrate with, and this is a pretty extensive one. So I typically use that. Even in my book, I use some extract files from it. I extract them to CSV and stuff so we can query and create things around it. Well, imagine you have a database. If AdventureWorks was using SQLite, they might have a file like adventureworks.db. The main thing is the .db extension tells you that this file contains a database, an AdventureWorks database. So it's just a file. Now, Oracle and SQL Server and all those, they also just have a file, but they kind of put it through layers and put it in a directory which is protected and don't want you to touch it. But SQLite it's just sort of out front. Now imagine we have these tables. To get to the database, we would go through the SQLite API, and in this case R, so R would have a SQLite package and library, and then the DBI library, which is the standard database interface, would be used in conjunction with that to get you to the database, and then you just have your R program. So it's pretty straightforward. It's very easy to use once you have everything installed. What do we get that's kind of R specific? Well, one thing, when we do a query in SQLite, we get a data frame returned, which is really convenient because now we can use all our dplyr and all our other kinds of slicing and dicing logic and data wrangling immediately. So that's a really handy thing, and we can send complex queries to the database. We can easily save the data frame to a SQLite table also, which we'll see. And we can also use SQL, which is what you'd assume, but you can use dplyr type of syntax when you work with SQLite tables. Now, as I mentioned, it uses the standard DBI interface, which first I was kind of taken back by that, like, oh wow, it's different, because I had been using Python with SQLite. However, it's good because that's the standard way you work with relational databases from R, so it kind of follows a nice standard, but then there's little extensions here and there that give you a little extra features for SQLite. Now, the content, the notebook I'm going to demonstrate, is available on github.com/bkafeki/shared. You can find it in a folder called SQLite, R SQLite. So take a look in there. I'll try to remember to put it in the comments, but I hear people always go, where is it, where is it, where is it? You see it here. It's not difficult to just type in that URL if it's not in the notes, so just find it. I actually have all my content on github.com/bkafeki/shared, so you'll find lots and lots of stuff out there. And R SQLite is the folder. The other thing I want to mention, if I hadn't already, is if you're on LinkedIn, feel free to connect with me and mention that you saw my videos, you like it, you've subscribed, and yeah, it's good to know and connect with people and expand your network that way. And also you'll get notifications of where I'm speaking and what I'm doing. So let me toggle out of here for a minute. I'm going to go over to a notebook, and recently I've started switching over to Jupyter Lab, which sounds like another video for me to do. And Jupyter Lab is just the next version of Jupyter Notebooks. I like using this over, say, RStudio. RStudio is great for working, but I like this more for teaching because I think it's easier to sort of see what people are doing in the blocks of code. And so yeah, I'm going to use Jupyter. The first thing I would point out is there's a nice link here when you get the notebook, which is SQLitetutorial.net, and that's a good place to start. I took some ideas here, but a good place to kind of get your feet wet, learning about SQLite. To install and use SQLite, you just say install.packages are SQLite in quotes, and you're good to go. If you get an error, you may have to do something like this, where I added the repos so that it will know what mirror to use to get this, because I got an error for that. And if you don't know what mirrors to use, there's a link right here. You can go there, and that will bring you to a list of mirrors so you can figure out what's closest to you. All right. Once we have it installed, then we're going to say library or SQLite, and that will bring that library in. So let me run that. I'm using Control Enter to just run it. I'll do Shift Enter, which will advance to the next cell as well. And now we're here. Now I don't need to bring DBI in. I think it should automatically do that, but I'll do it anyway just in case. But when you bring in SQLite, it normally comes back and says, I'm going to load in DBI as well. And by the way, when you install SQLite, I believe it will also install the DBI library if it's not there. So you should get everything. But if not, just remember, it does depend on that. Now, the first thing I want to demonstrate that I think is really a cool feature is that you can create in-memory databases. Why would I want to do that, Brian? That sounds crazy. Well, you're going to bring different data frames together, and data frames are typically in memory anyway. But you want to be able to query things and persist them and do stuff. So you might be working all day on something. Well, a nice feature is that maybe you don't want to really save this to a physical file. Instead, you can just do an in-memory database. It will run fast. It will allow you to store many tables, and you don't have to kind of keep data frame names straight. You've got a catalog. It knows all the table it's got. It can run SQL queries. So you've got all the benefits of a SQL database, but it's not actually on disk, and it's going to be much faster because it's in memory. It's a particularly good thing if you happen to have a lot of memory. My machine has quite a bit of memory, so I would use it. But yeah, so it's a pretty cool feature there. When I do this, I'm going to establish what's called a connection, C-O-N. I'm going to use the DBI function, db connect, and then I tell it the driver. What am I trying to connect? Which is SQLite, right? And then memory, colon memory. Typically where it says colon memory, colon, it would have a path to the DB file. If the DB file doesn't exist, as we'll see in a moment, it'll just create it, so no big deal. But here it's going to be an in-memory connection, in-memory database. Now I want to take a look. I'm going to use empty cars to sort of demonstrate something. So what I'm going to do here, just so I don't get too many rows here, I wanted to demonstrate though. So I'm going to use empty cars to demonstrate just how easy, you won't believe it, how easy it is to bring a data frame you've got, however you've created it, doesn't matter, and put it into your database. Now I've got a link here. I put some links in this notebook as I go through here so you can get references, because this particular site, rdr.io, is a really good reference. First, I have this command. If I want to remove a table, I can just run this command. This table doesn't exist yet because it's an in-memory database, but I could remove it like this. So again, this db and then the function of what you're doing is typically what you want to do. Now, db write table is going to take a data frame and persist it in the database as a table. The parameters are the connection object we created to the SQLite database, the name of the table we want it to be called in the database. So I'm using the same name twice here, but I put it in quotes because it's a textual parameter, right? And here I'm going to say I'm passing empty cars, but I'm not passing everything. I'm only going to really pass the first 5 rows, all right? And that's it. And then I'm going to say db read table is just going to say, basically it says read and dump the table back. And lo and behold, I know you're riveted, but this is pretty cool. So it just saved the table and then displayed some data back. Now, because it's in memory, if I close the notebook and shut down my session, it will blow it away. If it was a permanent data, if it was an actual file, it would keep it there forever. All right. So now I'm going to do something here. Now notice when I did this, I didn't give it any extra parameters, but a parameter I can give it is append equal true. And what I'm going to do here is now say, okay, go from rows 6 to 10, add more data to this by appending it. And there you see it added new rows. So that's pretty cool. But maybe I don't want to do that. Most often when I'm doing tables, I tend to say like truncate and load. Truncate is a database statement to say clear out the table, because I may be getting a new CSV file and I'm replacing it. So if I want that, I can use overwrite equal true, and that will replace the table. And now I've got the whole thing here. And notice though I replaced it with rows 1 to 10. I could have done the entire table. I could just say empty cars, but I'm giving it a limit because I don't want to put too much in there, say. Okay, here I want to say overwrite equal true, and one of the things you'll notice, it's got that row name here on the left, the name of the car. Maybe I don't need that, so I can turn row names off by saying row names equal false, and then you'll notice I don't get that anymore. So that's pretty cool. Now one of the things that happens to me all the time, whenever I'm using a database, I forget what things are called because I don't have a great memory for that. So I like some way to do it. Typically if I'm in SQL Server Management Studio, I tend to just use the left side, and you have this navigation for folders, and you can just click it down like a folder and see column lists. There's all different ways. DB list fields will do this for you. So that's telling me, okay, for empty cars, these are the names of the columns. Now I'm also going to use another thing here. Let me do it this way. I'm going to say head. Another built-in data frame is cars, as you know, and there we can see speed and distance. So what I want to demonstrate here is a different type of statement. Before we've been saying read table, right? And we've been persisting a table. What if we write a table, but now we want to issue a statement against the database? This is called DDL, data definition language. But any kind of statement, sometimes you want to do things like execute a store procedure. If it's, by the way, our studio, SQLite does not support store procedures, at least not SQL written store procedures. But anyway, but I want to issue a statement like inserting. So first I'm going to insert, create a table, cars. So I'm just taking 3 rows of the cars data frame, and I'm going to call it cars. And by the way, I do want to call attention to it. I think this is kind of a cool thing, but I can, as long as whatever I use as a function returns a data frame, I can use the DB write table to pass in and persist. So I can use the head statement to just return 3 rows from the data frame and persist it, which I think is kind of cool. Once I persisted it, I'm going to do a send statement and do an insert. Now it's an important thing to understand, and this can be confusing for people. To me, I've gotten so used to this, but I want to make sure I point it out. When you're using a SQL interface, whether it's using like ODBC or Microsoft has theirs for SQL Server or any of those things, there's usually a distinction made between a statement which just hits the database and says drop a table, do a vacuum statement if it supports that kind of thing, create an index. Those statements don't return data, right? They just say do something and it does it. But a query like select something blah blah blah, that actually returns results. So this statement, DB send statement, is saying look, execute this, just do it. When we'll see later if we're querying more, other than we saw read table, but there's ways to send queries where we don't want to actually just execute it. We need to get the results back. It's not, and it returns like a data frame. So here I'm going to be saying send the query to a connection, insert a row, and then I'm going to be displaying a couple of things like has it completed as a flag, how many rows were affected, clear the result, and then read the table and show me what's in there. Now I've noticed when you use these functions, they tend to return a Boolean yes, no, true, false, meaning did it work. So as you go through here, you can see true, true. So I think when it did the send statement, it returned a true. Then it says had completed true. And then we get here how many rows were affected. That was by the insert. Excuse me. That would be the first one when it inserted the 3 rows. And then finally has completed. And then it, let's see, then the read table just displayed everything there. So we've got the output here. So we can see that it's at 112223 and excuse me 112233. All right. So which ones of these are matching to what the true statements? This is how many rows affected. So this would have to be has completed is true. And this one must be the send statement came back true. So that's what I'm thinking it did. Or it's the right. So you have to kind of figure out which one's a Boolean here. But my main point here is that we are doing a send statement, and it will return whatever comes back, if anything, to rs, the result. And then we can see that it actually inserted our rows. That's it. But just to also, in your own mind, keep a little bit of a distinction between returning results and just issuing a statement. Depending on the thing, some of these interfaces actually make you do a lot more work. Microsoft has something called IDEO.net, which you go through a lot more. I mean, it's powerful, but it can be a lot more work there. Okay, so now when you're done, the connection is sort of pointing to the database, holding things open. So to get rid of it, we can just say db disconnect. Boom, gone. All right, so that's the end of our in-memory database lesson. And I could split here and make you come back to another video. I'm not going to do that because I think we're in a sort of flow here. So you can bear with me. I think you'll find this really cool and interesting. So now for something completely different. I love Monty Python, so I like to reference it. A database that you can get to train with on SQLite is called Chinook. So similar to AdventureWorks that Microsoft uses, Chinook is a database. It's available at this link that you can get in the notebook that I put in there. But I'm also going to include the Chinook database in this folder when you go on GitHub, so you can get it there if you want to. But this, I like this little image because it shows you what this is. So you got a lot of different tables you can join, you can slice and dice. It's a good database to practice with, especially joining, filtering, aggregating. So have at it. So this time I'm going to say db connect. We did this before, but notice the big difference is I'm saying chinook.db. Now if that file, chinook.db, did not exist, it will just create it. Not a problem. It'll be an empty database. So it's just going to create the file. But if it exists, it will just point to it and give you access to whatever's in it, whatever tables are there. It's returning again. I'm just using con, by the way, con as a name. I could call it XYZ, I could call it whatever I want. But that's the connection object that I use to reference this connection. And once I point to Chinook, now one other thing is, this is in my current folder, current directory, so I'm good. But if I needed to, I could point a path here, like C:/ blah, 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 or relative path. I can do that here as well. So let me connect. Then let's list tables that are in this connection. And we can see that we've got all these tables. And there's a couple I actually created. You can see I persisted empty cars and a couple of other things here for fun and interest. But you can see that all this stuff it shows us is there. Now another query I can use, which is probably the one I would use a lot more than get table, is get query, because get query lets me run any SQL I want. So if I just want a single table, I can just say, like here, select asterisk from artist, and I get that. But if I wanted to join in things, I can get that too. So db get query is more powerful in what it can do. It returns a data frame, but let me just db get query, pass in the connection, and I'm just going to get the first 3 artists from the artist table. And there you go. Now here's what I'm going to do is same thing, but as I mentioned, the query returns a data frame. So it's going to return the data frame to artist df, and after I run that, I can just run this and get that here. All right. And here I can also say, now that I have this connection, db list fields, maybe I want to know what's in the invoice table, and there it is, I can see it. So that's pretty cool. Another thing I can do, which is a little different, and this is interesting because, by the way, this whole idea of this get query, this get query is a very DBI R thing. Typically when you're using RStudio, you run your query, but then you use something called a fetch and tell it what you want to fetch back. So here, if I was doing it the sort of more SQLite way, I would say db send query, pass the query, and then I would say some sort of fetch statement. Now again, this is still wrappered in the DBI interface. So I'm going to be running this now. Instead of get query, I'm saying send query, and then if I have to do a fetch to get the result. So it's like, okay, I got the query, but I'm not doing anything yet until I say fetch, and then it will get the results back. Now it's important because if you happen to be somebody who, say, like is doing a web app or only want chunks of the data at a time, then this is the way you'd want to do it, because you say fetch and you can control how much you fetch at a time, and I have an example of that. So the results are going to go back into RS here. So let me run that, and you can see it returned the results. Now I set this only 3 rows back. That's why you only get 3 rows from that. Now a nice thing about when you do this results back also, which you can't do with the get query, which I find a bit annoying, but no, I can pass in the rs to db column info, and not only does it tell me the names, but it tells me the type and the length, which is kind of handy because it's nice to know what the data types are. The clear result is a command you want to do when you're done using this send query, because you want to clear out the result set and kind of close things up. So as I mentioned, we can do chunks of things. So here I'm going to say select asterisks from artist, limit 9, and then here I'm going to set up a while loop. While, and this function says while it basically while it has not completed, then keep fetching and store the results from db fetch into this variable called chunk, then print the chunk and see how it goes. So we can see by this, and by the end, yeah, clear it out at the end, but you can see this is my first chunk because I remember I asked for 3. So I get the first set of rows, the second set of rows, the third set of rows. So this is a situation where, maybe you have like, well, something crazy like a terabyte of data, and you want to pull in all these rows, but obviously you can't pull that all into memory. So you might pull it in a chunk. You could then write that to a database or write that out to a file, whatever you want to do, and then get another chunk. It's particularly used obviously in things like applications like web apps, where they'll say display as 20 rows of data and then get another chunk and display another 20. But the idea is you can ratchet and control, kind of put a governor on that and take the data as you can handle it. Again, db column info. Can't do this now. Why? Why did I get an error? Because I cleared this out. This object clear result rs says it's gone, so I no longer can do anything with it. All right. So I just want to demonstrate a little more about this before we wrap up for the day. I want to create a query now that's more robust than before, and I can do a lot of things in a query. This is not even really getting to the surface. I can create, we'll see other things, but CTEs I won't show you, common table expressions, but those are really powerful. But here I'm going to say selecting some data. I'm going to be joining albums to artists to customers. I'm going to be grouping, so aggregation, right? I'm going to be ordering, but I'm ordering by a summarized aggregated column, the count. And I'm going to limit it to 10 because I don't want too much data. But you can see also I'm doing here a case statement. Case statement is really powerful. So what it does is it lets me to write logic about a column, do any kind of comparison type of idea, and translate something. So here I'm saying, for instance, case country. If the value of country is USA, then I'm going to say this is domestic. Otherwise, I'm going to say it's foreign. Now this I actually got off their website. I was thinking, how would I demonstrate this? And they had it. It's that link, and then I can call it this. So let me create this. Now I'm creating a query variable. In other words, I want to be able to just create that variable called my query, and now I can pass my query into db get query, and I get this nice result set suitable for framing. So you can see it's pretty cool, and again, that's not trivial logic. I know you guys out there, you're big into R code. You say I could do that in 10 minutes with dplyr, but it's still a pretty cool thing. And I mentioned before, another way, I said I did a send statement before. I can also do db execute, and this is going to say drop something if it exists. But anyway, I just wanted to, before I go over here, so you can see I can do complex logic here. What I want to show you now, though, is I can also take that complex logic and make it a view, which is really it's a saved query. If you haven't used databases much before and you don't know what views are, they take SQL statements and they put a name to it. They say, okay, this query statement is this. It also does optimizations when it does that to make sure it knows the fastest way to give you that result. It does not duplicate the data. It does not do any saving of data when you create a view, which is nice. It doesn't always perform as well as just querying straight data does. However, we can see here I want to create a view called sales by country by artist. So I'm going to issue this statement using db execute first to drop it if it exists. I say if exists because otherwise they'll give me an error, and I hate seeing ugly errors. And the 0 says, okay, no problem. Now, I'm going to create my query again. The only difference here, other than the fact that I'm not doing the case statement, is I'm not actually going to return results. I'm going to execute a statement that's going to save this query as a view. All right, so let me run that. And now I'm going to say db execute my query. And now that table, this view can be handled. This view can be treated just as if it were a table, which is a nice feature. So here I can run this, and it gives me the results of the query. So again, imagine you're doing, some data analysis. You're trying to prepare model features or something. You can you've got this complicated query. Like, I don't want to have to keep running this query. I don't want to keep thinking about this query and running that block of code when I need it. You could persist it as a view and then just treat that view as if it's a table in the database. So it's pretty cool. And maybe you're bringing in like CSV files on a regular basis and you're plugging them into like sales or appending to it. So another nice feature is if the view is querying against other tables and you add data to those tables, the view is automatically updated. And again, if I use dblist fields, and this time it's a real database, right? It's a file saved. I can also see the column names. All right, so I want to talk about something that anyone in the database world, I've had a lot of pain of these lately, actually, indexes. Indexes are a feature in a database that allows it to have a lookup, a method to look things up in the database quickly. It's something you don't typically have with data frames, but you can get in a database, which is another nice feature. So we have a table, if you look over here, called invoices. I hope you can see I'm doing the word on invoices over here. And invoices is a table, but I want to maybe do something where I want to be able to find an invoice date real quickly. So what I can do is say, okay, create an index. If not exists, I'm going to give it the index name, ix date. I don't have to give it any name in most databases, but I give it a name. And then I'm going to say it's the invoice table is where I want to do this. So I don't know if you can hopefully see this. I don't have the arrow thing to draw. And then I'm going to invoice date. So I'm creating an index on the invoice date of invoices. So if I go search on that, it's going to come back fast. That's the idea anyway. So I'm going to run this, and it said, okay, I've got an index now. And now when I go running statements like this, select from invoices or invoice date, and I give it an invoice date name. And in SQLite, it's a date time field, so you got to give it the format. But when I do that, lightning, right? Okay, it's 50 rows. I don't know if it's good. It really makes a difference on this one. But the ability to do indexes is a really nice feature, and not something you typically would think of in like data science and analytics, because you're so used to aggregating and kind of keeping everything. But imagine if you really said, I just need like a small subset, and I know you can sample and things, but you might say, why don't I just have an index on this, and I'll just pull out one day out of maybe 3 years of data and play with it. So that's one of these features where the indexes can really help you. Okay, so I'm going to do another one, right table, empty cars, as we saw before. I think we saw this. I can do the same thing. All this really shows me is, I tried to create this, but I already did this before. So it says it already exists in the database, and then I can query it. All right, that's about it. So in the same way we did this in memory database, we can do that also. Only this time, if I come back tomorrow and close this all up, it'll still be in that database. I have another lesson we'll look at later, which is going to get more into using other databases like SQL Server or Oracle or Postgres and pulling from them, and maybe even flat files, to kind of bring it all together and then really use that as a base. So SQLite can become sort of a workhorse to do our data wrangling and massaging of the data. So I think it's a really good use of it. All right, so we've gone through this, and again, github.com/bkafiki/shared, and then our SQLite. So wrapping up here, we talked about what SQLite is. I hope I convinced you that SQLite is really worth your time. It's a powerful database. I was really surprised when I started looking at it, and I've worked with databases for longer than I want to say, and I really like it. The reason to use it, I think when you're working in data analytics, you're going to use databases all the time. Usually probably not as much fun as you'd like, because you're like, I got to go through all these layers to get to SQL Server, Oracle, and there's all this security stuff. But being able to have your own local personal database for free that you can hand and slice and dice and trade with your friends is a really nice feature. And like I said, it's free, so why not? I think it's a good way to step up your skills. Great thing to talk about in interviews. Here's a trick for interviews, by the way. If you can bring up a cool feature like anything, you can sort of divert a question that may be getting into an area like, I don't want to talk too much about this. You can go into another area that's more fun and people probably don't know about. So they'll be like, wow, that's a great idea. I never thought about SQLite, and probably help you. We talked about the architecture of SQLite. It's very small footprint. I've been seeing other companies trying to create their version of this in commercial databases, and they're like 50 times, 100 times the space footprint, and they don't scale as well. So this is really, it's a real winner in that area. And we saw how much SQLite works really well with R. It took me a while, to be honest, to get my head around, because I've been doing so much with Python and SQLite, but R actually brings the sort of R features to it. And I actually like that once I got used to, oh, okay, I'm using DBI and I'm doing things. And I didn't even talk about some of the other features you can use to really do R syntax and then leverage SQLite, which I will do another video. So I hope this was useful. I hope you liked it. Tell your friends, like this, share, and please subscribe, because it helps me to know, okay, people are watching and subscribing and stuff. Reach out on LinkedIn and connect. Buy my book. I'm sure you'll find it riveting. Till next time, I'm pulling for you. We're all in this together. Take care.